The next is the properties of matter and their measurement. See, every substance have a unique characteristics properties. That is, these are called physical properties and chemical properties. Okay. See, the physical properties. That means the physical properties those can be measured without, that is observed, measured or observed without changing the identity or the composition of the substance. For example, color, order, that see, these are the melting point, boiling point. So these are the density. So these are the called physical properties. Then the chemical properties, that is the measurement or observation. The chemical properties require a chemical changes to occur. So that example is the acidity, the pH value, acidity, basicity, combustibility, like this. So these are called physical and the chemical properties. See, the many properties, that is matter such as length, area, volume, like this, time, etc. The quantities are nature. That's quantities. The quantitatively observation is represented by the number followed by the unit. That is, which is measured. There are two systems. One is that English system, another one is metric system. See, the two different parts, that is we were using the two different parts. One is English system, another one is the metric system. See, that 18th century in the France, they are more convenient. Some units are based on that international systems of units. International systems of units. So these are called in later SI units. So the SI unit we can easily measure, that is universally accepted in this system. So that is the 7 base SI systems are given. That is here I will tell you that length, mass, time, electric current, thermodynamic temperature, amount of substance, then luminous intensity. See, these are the 7 base systems of the SI unit. Usually length, the unit of length. The unit of length is what? So for example, length that can be so for example, in a room or area, some places you have to measure, mean, for example, 10 m. Here the 10 is the number and m is the unit, that is called meter. So here the length is measured by that unit is m, that is called meter. So that's mean the length of the path traveled by light in the vacuum during the time interval of the 1 by 299,792 458 seconds. Then next is the mass. Mass is usually we are using kilogram, kg, kilogram. The kilogram of unit is mass, that equal to the mass of the international prototype of the kilogram. Okay. Then time. The time, the unit is SI unit is seconds. The seconds, that is duration of 9,192,631,770 periods of the radiation, that corresponding to the transition between the two hyperfine levels of the ground state of the cesium of 1 33 atom. Then electric current. Electric current usually the unit is indicate that ampere, the unit is A. Then usually we are using sometimes electric current I. Okay, the ampere, that's the constant current which is maintained, that is the true straight parallel conductors of infinite length, that is the negligible of the circular or cross sections, and the placed, that is 1 meter apart in a vacuum, that would be produced between these conductors forces equal to 2 into 10 power minus 7 Newton per meter length, per meter of length. Okay, Newton per meter. Then thermodynamic temperature. The thermodynamic temperature using Kelvin, in symbol is K. So here the Kelvin of the temperature is the fraction of, that is 1 by 273.16 of the thermodynamic temperature of the triple the point of water, that is triple the point of water, so that the unit is K. Then unit of amount of substance. So unit of amount of substance simply denotes as mole. So the mole amount of the substance of the system which contain as many, that is elementary entities as their atoms in 0.012 kilogram of carbon 12. So the symbol simply we can use MOL, mole. Okay. Then suppose when mole is used in a elementary entity must be specified, and maybe atoms, molecules, ions, electrons or other particles are specified group in such a particles. Then luminous intensity is called candela. Candela. The candela is a luminous intensity in a given direction of a source that is emits monochromatic radiations of frequency, that is 540 into 10 power 12 hertz, simply hertz, H is it, that has been radiant, that intensity the direction of 1 by 683 watt per steradian, watt per steradian. So these are the 7 base units of the SI systems. The prefixes used in the SI system, that is 10. 10 is deca. So simply 10 is deca, simply D. 10 power minus 1. 10 power minus 1 deci, and symbol is D. 10 power minus 2 centi, C, simply C. Then 10 power minus 3 milli, that's M. 10 power minus 6 micro, that is mu. Then 10 power minus 9 nano, that's N. And 10 power minus 12 pico, that is symbol is P. 10 power minus 15 atto, femto. Femto, the symbol is F. 10 power minus 18 atto, A. 10 power minus 21 zepto, symbol is Z. And 10 power minus 24 is yapto, and the symbol is Y. So this is the minus one, and the positive symbol 10 power 2. This 10 power 2 is hecto. This simply H. 10 power 3 kilo. Symbol is K. 10 power 6 mega m. Then 10 power 9 giga g. 10 power 12 tera. Symbol is T. And 10 power 15 peta P. This is capital. All these are capital. Then 10 power, for example, kilo is a small letter and hecto is a small letter. The remaining things are from here itself. All these are capital letters using uppercase. Then 10 power 18 hexa E, capital E. Then 10 power 21 zeta, symbol Z. Then 10 power 24 is iota, capital Y. So these are the prefix used in the SI system. Next is mass and weight. Mass of a substance is amount of matter present in it, while weight is force, that is force exerted by gravity on a subject, that is gravity on an object. So mass of substance, that is amount of matter present, that is how much space is occupied. Then the weight is forces, that is force exerted by the gravity of the object. So so mass of the substance is here, mass of the substance is constant, but the weight may be vary from one place to another place. This is constant and this will be varies one place to another place. For example, in weight of the substance in 1 kilogram of in earth crust mean, suppose if you use that 1 kilogram of that substance, that object, you have to dip in water, that weight will varies. So the place changes mean the weight also changes. In the same time, suppose that 1 kilogram of the substance, if you take into this space mean there is also weight is changes. So that mass is constant. Okay, mass means that constant, that matter, that is some occupied space. Okay. Then the SI unit of mass usually we are using, that is kilogram. That it is a fraction of what is 1 kilogram is equal to what, 1000 gram. So due to the smaller quantities, we can use the chemical balance, that is called analytical chemical balance. Then volume. So volume has the units of, that is length power cube, that is, so SI units, volume has units of meter cube. Suppose we are using that, but again suppose we are using chemical laboratories. In chemistry laboratory, the smaller volumes are used. Usually the smaller volumes are used. So that volumes are often denoted in centimeter cube or decimeter cube. So these are the units in the chemistry laboratory. In common unit, for example, in common unit, that is liter. Common unit is liter, which is the symbol is L, which is not an SI unit. This is not an SI unit. It's used for the measurement of the volume that is in liquid. So 1 liter is equal to 1000 milliliter. So 1000 centimeter cube is equal to 1 decimeter cube. So this can be for example, and that volume usually in for a cube, here the volume of this whole this thing is, that is 1000 centimeter cube. So that is the 1000 centimeter cube or 1000 milliliter or 1 decimeter cube or 1 liter. See here, suppose if you cut like this, each one centimeter means that will help to, that is up to 10 times. So each one having 1 centimeter. So 10 centimeter is equal to 1 decimeter. That is 10 centimeter is equal to 1 decimeter. So that this means this having 10 times, like a 10 box. So that each contains 1 centimeter. One box contains the volume of one box is 1 centimeter cube. So that's mean 1 ml. So that this particular part 1 is, that is 1 centimeter. So this is called 1 centimeter. That is the different units are expressed in this volume. Okay. Now the laboratory volumes of a liquids or a solution can be measured by the graduated cylinder. Okay, that is also called a measuring cylinder and burette measuring cylinder or graduated cylinder, burette, pipette, etc. So standard flask like this, round bottom flask. So the volume of that volumetric flask, that is a titration flask, used for the preparation of a known volume of the solution. Then the measuring devices we can visualize. I think you are seen in the laboratory. This is titration flask or volumetric titration flask or conical flask, and this is a standard flask. Okay, so we are having various like this, the measurement unit. Then next we will discuss density. Here the SI unit of density is, that is density, you can denote the symbol D or sometimes rho. So this is the symbol of density. So D is equal to mass by volume. Mass by volume. So here the SI unit of mass divided by SI unit of volume. So mass usually we are using kilogram. So that kilogram, volume we are using meter cube. So meter cube. So that unit is, we can use kilogram by meter cube or kilogram meter power minus 3. So these are the units of density. So the unit is quite large and chemists often express in density usually gram per centimeter cube. Gram per centimeter cube. That's the volume is expressed in centimeter minus cube. Okay, usually volume expressed in centimeter cube. Okay. Then temperature. The temperatures are, the common scale is degree Celsius. Yes, degree Celsius. So degree Celsius, that is, and degree Fahrenheit and Kelvin. So these are the common scale. But in SI system we are using the Kelvin scale. So that is the thermometers based on the scales, that is Kelvin, Celsius, Fahrenheit, like this. This thermometer Celsius scale are calibrated to 0 degree to 100 degree. This means that two temperatures are, that is a freezing point and the boiling point of water. The freezing point of water is 0 degree Celsius and the boiling point of water is 100 degree Celsius. That means the point of that the Fahrenheit scale represented between that 32 Fahrenheit degree Fahrenheit to 212 degree Fahrenheit. So this is a Celsius scale, degree Celsius scale, and this is a degree Fahrenheit scale. So the temperature of two scales, that is the related to each other, that is F Fahrenheit, degree Fahrenheit is equal to, the formula is 9 by 5 into degree Celsius plus 32. Okay, this is a conversion of Celsius to Fahrenheit. Then the opposite, the same rule we are following, the degree Celsius, just opposite of this, then the Kelvin, that is degree Celsius plus 273.15. So here the degree Celsius, Fahrenheit, degree Fahrenheit minus 32 divided by 9, so this into 5. Okay, so the 9 by 5 is equal to what? 1 by 8. So we can use the simple trick. We can see some how to convert degree Celsius into Fahrenheit, degree Fahrenheit, and degree Fahrenheit to degree Celsius. Simply, that is the 0 degree Celsius is 270 in Kelvin, that is degree Celsius plus 273.15. So that Kelvin is equal, that means 0 degree Celsius mean 0 degree Celsius mean you have to add 273.15, approximately 273. So the Kelvin scale is equal to 273 Kelvin. 1 degree means 273, so 274 Kelvin. So this is the approximate. The accuracy is you have to add 0.5 or 15. Okay. Now we will see some examples. See, this is degree Celsius to conversion of degree Celsius to degree Fahrenheit. The opposite, degree Fahrenheit to degree Celsius. See, these are the examples. See, I will work out this example. First, 35 degree Celsius convert to, so that 35 degree Celsius to what is that? Fahrenheit. See, already we know that the formula is F is equal to that. You have to convert degree Fahrenheit, so that F degree Fahrenheit. So F is equal to degree Celsius into 9 by 5 plus 32. Okay, so this is the formula. Just you can the fraction you can use, that is F is equal to 1.8, that is 9 by 5 is equal to 1.8 into degree Celsius plus 32. So here that 1.8, the given degree Celsius is what? 35 plus 32. So just simplify it. This will be 35 into 1.8, that's 63, so plus 32, so 95 degree Fahrenheit. The first one answer is 95 degree Fahrenheit. Second one is, second answer, the question is minus 20 degree Celsius to degree Fahrenheit. So simply you can write F is equal to 1.8 into degree Celsius plus 32. So here 1.8 minus 20 plus 32. So simply the answer is what? So minus 20 1.8 is equal to minus 36 plus 32. So it will become minus 4. So minus 20 degree Celsius is equal to minus 4 degree Fahrenheit. So this is the answer. Then similar way we are using that Fahrenheit to degree Fahrenheit to degree Celsius. Degree Fahrenheit to degree Celsius. Here simply you can remember that formula is what? Already the given formula is degree Celsius is equal to Fahrenheit minus 32, understand, minus 32 into 9 by 5. That 9 by 5 is what? 1.8. So minus 38. So simply you can remember that minus 32 divided by 1.8. That's all. So here degree Celsius 104 degree Celsius, 104 degree Celsius minus 32. So that 104 minus 32 is what? 72. So 72 divided by 1.8. So 72 divided by 1. So 72 divided by 1.8 degree Celsius is equal to, that is 40. So 40 degree Celsius is equal to 104 degree Fahrenheit. So 104 degree Fahrenheit is equal to 40 degree Celsius. The next is minus second sum, minus 130 degree Fahrenheit. So in Celsius, degree Celsius is what? So using of that same formula, minus 130 minus 32. So it will become minus 162. So minus 162 divided by 1.8. So 1.8, that will become is minus 90. So here minus 130 degree Fahrenheit is equal to minus 90 degree Celsius. Minus 130 degree Fahrenheit is equal to minus 90 degree Celsius. So you can practice it. Some more example. Okay.